Access to clean water is essential to our health, our communities, and our lives. In utilizing existing river water rights, we are preserving nature's ability to filter and supply clean water. As droughts, floods, and waterborne diseases intensify with global warming, this natural infrastructure will become more important than ever. Pebble Creek is working to ensure that our rivers, streams, and lakes will be safe for drinking, fishing, and swimming in the future. This access to clean drinking water is essential to all forms of life. This is of critical importance to our children and the elderly, as well as our beloved pets. Aurora is located just east of Denver, Colorado. An estimated population of 310,000 residents call Aurora home. A population of this size in an arid environment which receives less than 15 inches of rain a year and is devoid of any groundwater resources can create difficulties in continuing serving the residents affordable drinking water. As the drought of 2002 and 2003 came to a close, Aurora was left with less than 9 months' supply in their reservoirs. This water management crisis emphasized the need for new source procurement in Aurora. The Prairie Waters Project was designed using existing water rights in the South Platte River. Careful considerations must be taken in using an urban watershed such as the South Platte as a drinking water source. Built in 1990, the Aurora Reservoir will be the final distribution point in our treatment process. This reservoir has a surface area of 820 acres and storage capabilities contain over 40 million cubic meters of water. The reservoir is refilled solely through snowmelt each spring, and as water patterns change due to global warming, supplies become even more limited. In order to protect from future droughts, existing water rights from the South Platte River must be integrated into our current system. The following video and subsequent presentation will outline how to make this all possible. Step 1. Riverbank filtration.
Here is the South Platte River that water will be drawn through to provide a flow for our 17 alluvial wells that will pump 10 million gallons a day. This is a scaled image of one of the 17 wells that will be placed along the river at a distance of 500 feet. The existing soil conditions will remove the majority of suspended solids as well as provide nutrient removal through microbial interactions. This is a preferred method because it uses natural processes compared to expensive membranes that require chemical addition and produce residuals.
Next up, calcite chip contactors. After extraction from the riverbank filtration wells, the water will reach a passive reactive barrier composed of calcite chips. The calcite chips will aid in the removal of the phosphorus, and as seen in this scale demonstration, water will flow over the reactive barrier, and in the process, phosphorus, nitrogen, BOD, COD, and nitrogen levels will be reduced. The water will travel about 0.2 meters per hour after the extraction wells after 30 days of treatment in the soil. Concluding North Campus treatment is aquifer recharge and recovery.
The water is pumped into the basins through 4 injection wells, where it percolates through more sand and gravel over a longer period of time. This process is a continuation of the riverbank filtration and will remove even more contaminants.
Our advanced oxidation process will begin treatment on the South Campus. The advanced oxidation process has been requested by the client to provide the needed destruction of organic compounds of concern, which include endocrine disrupting chemicals, pharmaceutically active compounds, and pharmaceuticals and personal care products. The reason for the removal of these compounds is because extremely small concentrations in nanograms per liter affect all living organisms, including humans. Photocatalytic advanced oxidation processes like the one seen here is UV-H2O2 utilize UV light to provide energy to generate hydroxyl radicals that form a reactive species. In addition to UV light, a semiconductor of hydrogen peroxide will be used as a catalyst in the reaction. Granular activated carbon filtration will be used as a final polishing step.
Following the advanced oxidation process will be granular activated carbon filtration, Activated carbon is processed to maximize surface area for chemical adsorption and is used to remove organic impurities. Here you can see some granular activated carbon, similar to what you would find in a household Brita filter.
The treatment processes and techniques outlined in this video will allow Aurora to meet stringent water quality regulations today without compromising the needs of future generations.
Thanks, Pebble Creek.